Only a few weeks ago, astronomers believed our third recorded interstellar visitor, 3I, Atlas, would pass quietly through the solar system, just another faint traveler crossing the sky. Instead, the unexpected happened. In less than 2 days, this mysterious object brightened 6 times more than predicted and expanded a vast green cloud of gas and dust, half the width of our Sun. Now racing toward Mars at nearly 70 kilometers per second, Atlas has slipped beyond the reach of most Earth-based telescopes, lost in the glare of the Sun. Why is this object breaking every rule of comet science? Could it be revealing hidden physics, or concealing something stranger? A speed beyond familiar worlds at present, Atlas is about 2 astronomical units from the Sun, roughly 300 million kilometers away. Even at that distance, it moves with astonishing velocity, 58 kilometers per second, twice as fast as any planet. To compare, Mercury, the speed champion of the planets, orbits at just under 48 kilometers per second. At that speed, Atlas could travel from Earth to the Moon in just over 1 hour, a journey that took Apollo astronauts 3 days. By the time it reaches perihelion at the end of October, its speed will peak at nearly 68 kilometers per second, pushing the upper limits of what natural solar system objects ever achieve. A coma that defies expectations. Though the nucleus of Atlas is small, somewhere between half a kilometer and a few kilometers across, it is hidden within an enormous envelope of gas and dust. This coma, glowing with a strange green hue, has ballooned to 600,000 kilometers across, almost half the size of the Sun. Such a scale is rarely seen at this distance. It means sunlight is scattering off unimaginable amounts of material, hinting at a composition unlike ordinary comets. A one-time encounter trajectory calculations confirm what astronomers feared: Atlas is not bound to the Sun. It follows a hyperbolic orbit, meaning it will visit our solar system only once before heading back into interstellar darkness. It will never return. There is no danger of collision. Its closest approach to Earth has already passed at about 1.8 astronomical units, nearly twice the distance to the Sun. What makes it urgent is not threat, but opportunity. A narrow window exists to study an object from another star system, and that window is rapidly closing. The Mars campaign. As Earth's vantage point dwindles and the comet slips beyond the reach of ground-based telescopes, the responsibility for observation shifts to the robotic explorers stationed around Mars. Suddenly, the red planet becomes humanity's forward outpost for interstellar science. NASA's Mars Reconnaissance Orbiter, built to study Martian geology, now points its powerful high-rise camera toward the intruder. ESA's Mars Express and the Trace Gas Orbiter, designed to probe Mars' atmosphere, are redirected to dissect the chemical fingerprint of Atlas. Even MAVEN, a spacecraft launched to study solar wind and plasma interactions, joins the campaign. Together, this armada of machines becomes the solar system's most unlikely observatory. Their instruments will record Atlas's shimmering green glow, the expansion of its vast coma, and the turbulence of particles streaming into space. With every frame and spectrum, Mars transforms into a cosmic listening post, catching whispers from a visitor that may never return. What comes next? As Atlas races toward its close approach with the Sun in late October, the world holds its breath. Astronomers outline 3 dramatic possibilities for its fate. Fade away. The comet's buried ices may already be running dry. If so, the glow will diminish, the tail will shrink, and Atlas will quietly vanish into the abyss, a spent ember drifting back into interstellar night. Final flare. A sudden eruption of carbon dioxide or deeper volatiles could produce one last, spectacular outburst. For days, Atlas might blaze in brilliance, a dying firework marking the end of its long journey. Disintegration, the most violent possibility. If solar radiation and tidal forces overwhelm the fragile nucleus, Atlas could fracture into dozens of shards. Each fragment would carry its own trail of dust, creating a spectacular, but short-lived, celestial storm. Whichever scenario unfolds, the comet is more than just a curiosity. It is a once-in-a-generation chance to study how an interstellar object responds to the crushing stress of a foreign star. A messenger from another star 3i, Atlas is not a local wanderer. It is a traveler from beyond the Sun's domain, a fragment of another system's ancient story. Locked within its ices are molecules forged in a nursery light years away, perhaps even in the same kind of molecular cloud where our own sun was born. Its speed alone, tens of kilometers per second, marks it as an outsider. Its emerald glow, enriched with exotic chemistry, sets it apart from familiar comets. Even its strange anti-tail, pointing sunward instead of away, hints at dynamics never before observed. To scientists, it is a messenger. To philosophers, it is a reminder. The solar system is not an island. Our skies are open to visitors, objects from other suns, shaped by alien environments, carrying stories that predate Earth itself. The human challenge: what will we do with these fleeting gifts? Oumuamua passed before we had time to prepare. Borisov gave us only a glimpse. Now Atlas offers another opportunity, and soon others will follow. The challenge is clear: to build the tools, the missions, and the resolve to intercept these travelers. To capture samples, to decode their chemistry, to read their ancient signatures before they slip back into interstellar dark. For humanity, each visitor is a test. Can we observe with clarity, respond with speed, and learn what they carry? Or will we only watch them fade, forever wondering what secrets escaped us? Beyond the horizon. As Atlas hurtles past the sun and vanishes into deep space, its fate sealed, it leaves behind a legacy larger than itself. It has sparked a global campaign of science, turned Mars into a watchtower, and reminded us that the universe is not silent. Every so often, a traveler arrives, briefly touching our skies, briefly sharing its light. These are not just comets. They are bridges. They are proof that the galaxy is alive with motion, exchange, and mystery. Atlas may crumble, flare, or fade. But its true gift is perspective. The awareness that our solar system is part of a greater web, stitched together by stars, dust, and wanderers that carry whispers from one world to another. And one day, perhaps, we will not only observe